Hello, everyone. Welcome to the lesson. Let's first look at homework assignment 6. M2 chapter 4 limits. The last assignment. I returned this assignment to you, I think on Wednesday this week. Now, not many students have to do corrections, but if you do, or even if you got some remarks from me, you need to listen carefully. Question 20. This one I mentioned before, there are two methods. The first method is the standard method. In this method, you're using this formula, which I call the definition of e to the power x. Now here, x is -1/3. The answer should be e to the power -1/3. You do not have to write the radical sign, the third form. You don't have to. The second solution, this method is the one that I used. Now here I'm showing you again. Same answer. Question 21. Question 21, you don't have to use a special limit because this limit is equal to 0. And that's something you should know. E to the power x, when x tends to -infinity, only -infinity, this limit is 0. It's not the same when x tends to positive infinity. It's not the same. Okay. 22, this is the answer. 23. Now, starting from 39, I think you have to deal with the negative index. And this is one way to deal with it, to take it out. Now, some of you didn't, but you can. I suggest you to take it out. Because when you do, you will have a function that has no problem. A good function. I call a good function, meaning this limit at 0, it's continuous. You may not notice that. E to the power -x at x equals to 0 is continuous. You can just do the substitution. So it's recommended to take out e to the power -x. And then you have a special limit here. Moving on. Question 40. During the previous assignment, I marked a lot of your homework and I mentioned, oh, you don't need to do that. Meaning when you see this special limit, you don't have to change it to the reciprocal. Now you don't have to flip it upside down. You don't have to. You don't have to. So here I remind you again, you don't have to flip it. Okay, if you did, you shouldn't. And also sine 4x doesn't have to, you don't have to change sine 4x to a smaller angle. It doesn't matter. You can keep sine 4x, no problem. Question 41. Now this recommended method is to take out the negative index. Now you may not see it, but to be perfectly clear, this is e to the power -x taken out, e to the power -x taken out, and then they delete each other. And I think this is the quickest way to get rid of the negative index. If you didn't get rid of the index, I think you should, unless you're very fond of negative index. I don't believe that. I don't think anybody is very happy with the negative index. Anyway, now if you deal with that, then you will have three parts. One part is the special function. One part is the special limit. This part, the second part, is a good function. This function is continuous at 0. Very similar to e to the power x, very similar to e to the power negative x. They are good functions at 0. Is that okay? I hope after the explanation, you should finish the correction with no problem. Try to make it perfect. Let's move on. The next assignment. The next assignment is the first principles to find the derivative or the derivative function from the first principles. Question 15. This is the first assignment, by the way, the first assignment. Question 15. dy dx, the derivative function, is equal to, now during the lesson, I use another letter h. I didn't use this weird delta x. Although in the textbook, the examples use delta x. Now here, delta x serves the same function as h. It refers to a very small increment. Okay, it's just very difficult to write. So I didn't choose this one, but it's very common in textbooks. Remember, delta x is not delta times x. Delta x is a whole character. You must regard it as a whole. It's just equal to h. It's like my name. My name is Chen Lucy. Sorry, I don't know. Chen Lucy. Now, I don't write this part separately. Do you know what I mean? It's together. Together. I hope you understand what I mean. It's not delta times x. Okay. Now, this is equal to f of x plus delta x minus f of x. This part you must get it correctly. This is y minus y divided by x minus x. Sometimes I will say it very shortly. I will say it very short. I will say delta y over delta x, meaning the difference y over difference x, okay? Y minus y, x minus x. And then you simplify. And after simplification, you will send delta x to 0. So in the final, the second last line, you will write 0 here, 0 here, right? Only send delta x to 0. You should keep x. Okay, that's 15a. 15b, this is how you present your answer. You write that the slope is equal to this. This means the derivative at x equals to 3. If I never write this during the last lesson, now you learn. Now you learn how to write it. dy dx and then a stroke, x equals 3. Question 22. Now this is a difficult question because delta y over delta x and the delta y is very difficult to simplify. And I saw that you tried very hard to simplify it. Unfortunately, you have to expand this, which has 6 terms, and then expand this, which also have, this one also has 6 terms. But luckily, most of the terms can cancel each other out, and then you're left with a very few things. This is the answer. Question 23. Now this one is extremely difficult because it has fraction and the radical sign. The definition is the same. The concept part is the same. It's just your skill to find this limit. Now you need to rationalize it by multiplying the conjugate. Multiply the conjugate. And then you also need to expand the power of 3 using binomial theorem. The coefficients are 1, 3, 3, 1. Some of you still don't know that. Some of you are still expanding it in a weird way. And I pointed out for you. In your homework, I pointed out for you. And then after expansion, and then send delta x to 0. And then you are done. Now, in part B, notice the slope is equal to this f prime bracket 4. This one, I distinctly remember I showed you how to write this. It means the same thing. It means dy dx at 4. Okay, you write the slope is equal to dy dx at 4. And then you find out the value. Now, I chose these questions because I think that you can practice the derivative function using first principle. You can also practice the concept of the difference between derivative and derivative functions. That's why I chose these questions. The second assignment. This one I only returned to you this afternoon. I think it's very fresh. You should be relatively, because some of you only turned in the homework last night. You should remember this very well. Now this homework, I think you've done better. Done better. Question 3. Question 3 is the one that only looks for the derivative, not derivative function. However, if you look at the standard answer, it looks for this derivative function first, and then use the substitution to find the derivative. You can do that. You can do that. But some of you, I noticed that only 2 students, that is less than 10% in our class, less than 10% in our class, try to find the derivative using the first principles. That's also okay. Remember the derivative dy dx at x equal -1 by the first principle is equal to f of -1 plus h minus f of -1 divided by h. You can also do this. In fact, in very shortly, I'm going to show you a public exam question that you have to use this. Okay, now you can use the first principle to find the derivative function. You can also use the first principle to find the derivative. Now, during the lesson, I showed you both, but because so many questions need the derivative function, so sometimes you forget that. Derivative can also be found using the first principles. 19. 19 is similar to the last question in the previous homework assignment. It has a fraction and a radical sign, but this time I think it's simpler. You simplify, conjugate and simplify. 21. Now this one you need to expand again. Binomial theorem. Binomial theorem. 1, 3, 3, 1. Okay, and then answer. That's all. That's all. Please do the corrections very quickly. Not now, not now, but very quickly. Let me close this. Now, right now, let's go to the public exam questions I posted in the Google Classroom. There is this separate file, the PDF file I sent out along with all the other notes. I named it M2 Notes Pub Exam Questions. And inside it has a lot, not all, but a lot of questions that is like about the first principle, okay? Can you find that? This file, this file. Differentiation, the first file. This one is 5.1, 0.2, 0.3, 0.2, 0.7, but there's a separate file, public exam questions. It's not public exam about the whole chapter. It's just about the first principles. Let's look at them. Now you can look for the answers online. So I hope you can find the answer online. If you cannot, you can ask me. But today we're going to show you how to do 2018 during the lesson. Now you first try. You try a little bit. I'll give you 5 minutes. Now, if you succeed, you let me know by raising your hands. Now it's 8:22. I'll wait until 8:27. If you're done, let me know. Now 5 minutes is 5 minutes is up. 6 students finished this question. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Yeah. So I think you may need more time. Now you go, after the lesson, you finish this question. Okay. I will explain next time. Okay, just bear in mind there's some question like that here. Now, if you're done trying, you can also try 2019. Okay, I think these 2 years, the first principle question, they are a little bit different from the rest of the years. Okay, I will explain next time. I'll remember that. Anyway, look at 5.2. In 5.2, the title is Basic Rules of Differentiation. That means we want to figure out how to do the differentiation. That is how to find the derivative functions. Now you may think, oh, didn't we just learn how to find them? Yes, in a way. Last week, we did learn how to find the derivative function. We did learn that. But we found them through the first principles, which you should admit is not the easiest method. Even for a very simple function, to differentiate this function using the first principle takes a long time. Do you agree? Even a polynomial, even a fraction, a trigonometric function, an exponential function, the basic functions using the first principles, very difficult to get the result, although you can get the result. Now, if you did just now, you looked at the public exam questions, the function was a mixture, right? It's like polynomial times exponential. Now, how about a mixture? Like a polynomial multiplied exponential, how am I supposed to find that? Am I supposed to use the first principle all the time? It's not realistic. Do you know that? To use the first principle to find the derivative function every time is not realistic. Now, if we want to learn this calculus, the differentiation part, very well, you cannot base everything on your limit skill. Like seriously. That's why starting 5.2, we have these lessons that are named basic rules. Now in these sections, we are developing a simpler and more direct rule to find the derivative function more quickly. Now today, our goal is very, very small. We just need to know how to differentiate polynomials and maybe some simple fractions. Okay. Title: Differentiation of constant functions and power functions. Differentiation of constant function, I don't need to explain what that is, right? And power functions. Now, power function is a simpler polynomial. Okay, later I'll explain. Now, constant function first. The constant rule, I call the constant rule. How to differentiate say f of x equal k, where k is a constant. What is the derivative? The answer is the derivative of this constant function is equal to 0. We can prove this result through two separate ways. The first way is the geometry method. F of x equal k is a horizontal line at any point. The slope of tangent is equal to 0. Therefore, f prime x, the derivative function, is equal to 0. Of course, the derivatives are also 0, but the derivative function is also 0. Okay, that's the first one, first method. Second method, I can prove it through the first derivatives. F prime x, the derivative function, is equal to limit. Sorry. You need to write this down. H approaches to 0. F of x plus h minus f of x divided by h, and equal limit h approaches to 0. This is k minus k h. That is 0 basically. Is that okay? Because this is 0, you see, this is 0. So this is always 0. So it's 0, okay? It's the simplest. And you use it when you see a constant function. Now you may ask, how often is that? Quite often, quite often, often than you think. Second rule. Second rule is called the power rule. Power rule, what is the power? The power is this. I don't call it polynomial rule, because in this function you only have one term, and this one term has the coefficient equal to 1. So it's very specific. It's not a random polynomial, it's a monomial, and also the coefficient is 1. So these are these. Of course, n can be different. N can be different. So and maybe I shouldn't call it polynomial too, because power rule, n can be any integer, including fractions. Maybe I shouldn't call it polynomial. It's more than polynomial. It's more than polynomial, so it's called a power. Okay, it's called a power. Now, how to find the derivative function? Well, we found it for you. We found it for you, and you only need to remember the result. This is the result. Okay. Now the proof of this rule is not so simple, not as simple as the first rule. We will do that, I think, after a few weeks. Now, today we're going to prove a little bit. We will going to prove the case when n is a positive integer. That we can prove. Now, when n is a fraction, when n is negative, that we don't know. That we don't know. But the good thing is the result, it still holds for any value of n. But today we're going to prove n equals to a positive integer. Now, later on, you will see me prove other cases, but it cannot be done today. Cannot be done today. Over a few weeks, we will prove 90% of it. Look at the proof. You need to write this down. okay? I know you're not used to, but that's how you learn math. The derivative function through the first principle is equal to x plus h x divided by h. And it's equal to now I will use binomial theorem to expand the whole thing. Do you remember that? It's xm plus nc1 plus nc2 plus ncn minus x. This is equal to the first term is deleted. Now you have every term, but every term needs to divide h. And you're left with nc1 xm minus 1 plus nc2 xm minus 2 h. And the last term is ncm h to the power m minus 1. And then you will send h to 0. You will get nc1 xm minus 1 plus 0 plus 0 and plus a lot of zeros. And then you will get n times xm minus 1. That's why the power rule is correct for n is positive integer. Now let's learn how to use it. Textbook, page 11, classwork. Let's do this together. Let's do this together. Number 1, remember ddx? ddx, and then y. Remember ddx and then y. Y is -6. Okay, ddx y. That is to differentiate. To differentiate -6. -6 is a constant, therefore ddx -6 is equal to 0. Question 2. ddx this. This is a power function. Let's call it power function. This is the case when n equals to 6. So according to power rule, okay. Next one. This one, ddx xn, now n equals to -2, although we haven't proved it yet, but it's still true. The answer is -2, -2x, -3. Next one. 7/3 x 4/3. Now do not write the radical sign. Write the index, whatever the index is now, girls. Since you're in this subject, whatever index is, negative, fraction, or even irrational, you write the index, okay? Question 5, what is this one? Cassandra?
0.
0, correct. Question 6. Cindy. Cindy, are you awake?
-3/5 x -8/3.
8/5. Okay. Now, question 7 is harder now. Question 7 is harder now. Now you have ddx this. That right now it doesn't. You can't use the constant rule or the power rule. You must change it to the power. ddx x -4, and then use the power rule. Okay. Next one, the same. You must change it to the power and then use the power rule. Next one, number 9. What's the answer? Cherry.
It is 0. I'm not very sure.
It is 0, you're correct. Now this is E, not X. Therefore, this is the constant. You should use the constant rule. Okay. It's almost it. Almost it. Next one, another rule. Another rule. And this time we're not talking about another kind of function. We're talking about how you change a function a little bit. This is called the constant factor rule. What do I mean when you look at the formula? K is a constant. F of x is a differentiable function. Last time I explained what differentiable function is. Differentiable function is a function that the derivative function does exist. Okay. Which is, I mean, a lot of functions are differentiable. A lot. Only very weird functions are not differentiable. Okay. So you don't worry about that yet. Do not worry about non-differentiable functions. Probably never gonna see them. Never gonna see them. Anyway, this is the rule. It's written in the formula form. Now this time I didn't use the prime notation. I used the ddx notation. I'm searching for every opportunity to familiarize you with both of the notation. This time we use ddx. What does this mean? This is ddx kf is k ddx f, meaning to differentiate k times f is to use k multiply the differentiation of f. Meaning, if there is a constant, you can just like get rid of it. Just take it out. This also needs to be proven. I'll prove it. It's boring, but I'll prove it. ddx kf through first principle is kf minus kf divided by h. And that is equal to k limit f of x minus plus h minus f of x minus divided by h. Okay, and that is equal to k ddx f. Okay, now here when I take out k, I'm using the property of limit. Now just because I think it is precisely because of the property of limit that you can take out k, a constant. So we can very conveniently take out k when you are doing differentiation. Example 4. ddx y. I know a lot of you write dy dx, but it's also correct to write ddxy. Okay, means the same thing. That is equal to -4 ddx x cubed. Okay, so -4, and then this one I use the power rule. It's 3x2, and then the answer is -12x2. I'll show you another one. Now this time I will use the prime notation. Y prime is equal to 1/3 x -7 prime. Now I'm rewriting this fraction into another form, which I prefer. And then I will take out this and write this. I'm using the other notation, do you see? And then you get 1/3, 7x6. And then you get 7/3 x6. Not 6. Why do I? Sorry. Made a mistake. It's -7 x -8. So it's -7/3 x -8. Sorry. N is -7, not 7. Okay. Now you do that. You do that. You turn on your camera and then you do that, and then you raise your hand when you're done. Okay. I'm a Lee Chan. Tell me your first answer.
20x⁴.
Yes, correct. Donna, tell me the second answer.
-5/2x⁴.
Yes, correct. Very good. Okay, let me show you my answer. Now, because you are new to this, I recommend you write this dy dx and ddx, right? And then you take out 4, you still write ddx, and then the answer. The second one, you write y prime and then this prime, and then you take out this prime. It's just a practice, so you know how to use the notation. Now, let me tell you, the ddx notation is so hard. Maybe you try as much as possible. Now, when you write something wrong, I will know and I will remind you. Example 5. Now, the question is that to differentiate, you know what that means, right? And with respect to x. with respect to x, okay? Right now, there is no problem because you don't have anything else. You can only respect x. Wait until you have something else when there's no x. Maybe there's some other, maybe there's another variable, then you will not see with respect to x anymore. Okay, now ddx. ddxy is equal ddx negative 3/8 x to the power negative 7/2, and that is negative 3/8 ddx x negative 7/2 negative 3/8. Wow, handwriting. And then negative 7/2 x negative 9/2, you get positive 21/16 x negative 9/2. Second one, y prime. 5x negative 5/4 prime. 5x negative 5/4 prime. That's 5. Negative 5/4 x negative 9/4. Get negative 25/4 x negative 9/4. Okay, you do it. And then you tell me what your answer is. When you are done, raise your hand. Okay. Melissa, what's your answer for the first question?
Negative 6/x to the power 5/2.
Okay. You don't
And
have to
then-
write the fraction. Yes, it's correct.
Okay. And then the second one
Second
is
one, you tell me too.
negative 4/3 over 6 to the power 1/3.
Huh? You say again? Say again.
Negative
Negative
4/3
x
over x to the x to the power 1/3.
Yes, correct. Yes, correct. I just now heard something weird. It's correct. Okay, girls, this is the answer. The first one, you use the ddx notation. I write dy dx and then ddx. Okay, I take out 4, I have ddx again. And then the final answer. Second one, the prime notation. Now in your homework, if you didn't write everything correct, I will ask you to redo. Okay, don't make mistakes. Y prime. That's the whole thing prime. Take out 2 and then this prime. And then you derive and then you have the answer. The answer can be negative index, it's okay. Okay, just now Melissa gave us the answer with the positive index. You don't have to do that, guys. Just the negative index is okay. Next one. More rule, more rule. This one is also quite simple. That's the sum and difference rule. I think you understand this. Although I use the more difficult notation, the dx notation. I think you understand it. That means to differentiate a sum is the sum of the derivative. To differentiate the difference is the difference of the derivative. I'll prove it. I will prove it. D dx f plus or minus g is equal to, should I write that? Maybe just plus. I wonder whether or not later on the minus will be different. Just I'll prove one of it. Prove one of it. The first principle, fx plus h plus gx plus h minus fx minus gx divided by h equal limit the first limit plus the second limit and that is ddxf plus ddxg. Okay, it's a very simple rule. The proof is also very short. Now from here to here, I used the property of limit again. So you can see how the property of limit in the past, the properties of limit are affecting the rest of our learning. Without those, we can't prove these. You remember? Remember the limit of the sum is the sum of the limits. This is the limit of the sum is the sum of limits. Okay. Now the other one, the difference one is the same. Now I'll show you example and then you will do the classwork. This one, dy dx, that is equal to d dx, the first one, plus d dx, the second one, minus d dx, the last one. Okay. And then you take out 3, d dx, x7. You take out 6, d dx, x negative 8. And then you minus 0. I told you that we use the constant rule very often. You can see why we use that now. And then this is 3, 7, x6 plus 6, negative 8, x negative 9, minus 0. Then you get 21, x6 minus 48, x negative 9. You can leave your answer like that. You don't have to write the fraction. Classwork. When you're done, raise your hands. This time I will just check the answer with you. Okay. Should be done. Should be done. The answer. I don't ask you this time. I don't ask you this time. This is the answer. Okay. Yes, there. Now I'm using this notation now. The derivative, you can differentiate each parts and then put them together. This is the answer. Okay. Extra example. Extra example, dy dx. Now this is a fraction. In order to use our rule, I will split them into 3 terms. The first one is 8x. The second one is x to the power -7. The last one is 4 times x to the power -8. Okay. And I'll use the prime and the ddx at the same time. So yes, sometimes I do that. And then each time, each one. Okay. Now for the first one, it's 8. And then this is 1 times x 0. Later on, you will know it's just 1. For this one is -7 x -8. The last one is 4 -8 x -9. So you're getting 8. Now this is 1 times x 0 is not 0. That's 1. Okay. Plus 7 x -8 and minus 32 x -9. At this time, you turn on your camera and show me when you're done. This classwork. Okay. The answer is here. The answer is here. Now you can see I'm also skipping some steps. Like I'm using the sum and difference rule and the constant factor rule in one step. I separate them and also I took out the coefficients. You can also do that. And later on, when you're more skillful, then you can skip more steps, perhaps. Okay. Next one. How many rules are left? Not many. Not many. Now, the product rule. This one deals with when you have 2 functions and you multiply. Okay. Now, what is the rule? Now, f is a function. I didn't write f of x, but it's implied. I just didn't write it. I don't want this formula to look too long. But f is f of x. G is g of x. Now, the multiplication result is called the product. The derivative of the product is not equal to the product of the derivatives. Unfortunately, you would think, what is the product? You just differentiate them separately and then put them together. Then that's not. No, it's not. It's a more disgusting rule. That is to differentiate the first function, multiply the second function, and plus the first function multiply to differentiate the second function. In short, f times g derivative is equal to f prime g plus g prime f. Let me prove it. To prove it, you write it down fast. F g, the whole thing, derivative, according to the first principle, is equal to f g minus f g divided by h. The first principle doesn't change. It's the definition, it doesn't change. You see? How do I simplify this limit? Look, look. This I will minus something. And plus the same thing. And then divided by h. Now here I am creating a term, and then I'm deleting this term immediately. This is done because I know how to do it. If you don't know, then I don't know where to start, but because I know, I know this is something I need to add and subtract. It's the same as completing this square, you know what I mean? Because I need it, therefore I created. Otherwise it doesn't exist yet, right? Okay, now it's limit h. I'll put the first together. And the second limit. I'll take out f of x, but I will have g, okay? I take out g, and then I take out f. Do you see it now? I must see it now. I'll wait for, I will count to 10 in my mind. Okay. Now I'm going to be even more ridiculous. This is g, and this is a limit. And this is take out f of x, limit. Now it's just 1, 2, 3, 4 parts, do you see? Now, this part, g, so limit g. This part, the whole thing, the fraction, so limit the fraction. This part, f, take it out because it doesn't have h, so I take it out. Now here I'm sending h to 0. Anything that doesn't have h is a constant, so I take it out. Because that this f of x right now doesn't have h in it. So it's a okay. So it's a constant regarding x. Regarding h is a constant, and then the last one is a fraction. Okay, and now it's gx plus 0 f. This is ddxf plus x f of x ddx g. Now you realize that the first fraction, this fraction is ddxf by definition. The second fraction here is ddxg by definition. And there you go. Now this is g of x plus 0, that's x. That's x. So that is f prime times g plus f times g prime. Now because this is so complicated, so the application of it is also not easy. Sometimes you don't even remember to use it. Okay, in this case, ddx y. Find derivative ddxy. That is to ddx the first one and then multiply the second one plus the first one and then ddx the second one. Okay, so I will do differentiation twice, but separately in both terms. In the first term once, in the second term once. This is a derivative. This is another derivative. The first one. So I'll do them separately. Okay, for the first one is negative, and then x is 1, x 0, and then plus 4 is 0. Do you know what I mean? I'm not writing all the steps now. Not writing all the steps now. And then multiply the second one. Plus negative x plus 4, that's the first one. And then ddx, the second one. This one is 2x1 minus 4 times 1x0 plus 0. Or minus 0, sorry. But the same, the same. So you get this one is negative 1 x squared minus 4x minus 2 plus negative x plus 4 and then 2x minus 4, close bracket. Okay. Now until this step, you have to deal with the differentiation, but after this, you don't have. Right now, you have polynomial, and then you just need to simplify. To what extent, you may ask? To the simplest that's possible, to the simplest form. In this case, it's the most expanded form. Okay. I may be too fast in the differentiation part, but you can look at it again I'm doing -1 take out and then 1x0. That's the power rule. And then constant rule. This one power rule. And then take out 4, power rule again, and then constant rule. And you try. You try, okay? You try. Sorry, I still show you this. You try. Turn on your camera, you try. Okay. Sorry, Mr. Lau just told me that he has got COVID and couldn't come to the he can't come to school next week. So I will check for your PTA check or whatever. Let me know. Let me know. Let's continue. Oh, I don't have the answer yet. Do I have the answer here? No. You tell me. You tell me. You tell me what the answer is. If everybody agrees, then it's okay. Final answer. Final answer. Hey.
Is it 18x squared plus 38x minus 6?
I don't know. Do you agree, girls? Do you agree? No objection. No objection. Then fine. This is the answer. Girls, when you first use it, it doesn't feel very natural though. It doesn't feel, because you have to differentiate the first part and do that. You never do that in any algebra you have learned. Even with trigonometry, you don't do that. I think in trigonometry, you do sine, cosine plus cosine sine, right? But it's not the same, not the same. Example 8, product rule. A, F prime. This time, that's to derivative the first one, multiply the second one, plus copy the first one, differentiate the second one. At least I write this step correctly, okay? And then I know it's difficult, but I will do 8 plus 3x 1 over 2. I have to do that. Otherwise, I cannot even think about differentiate. This one, copy. And then 5 minus x negative 1 over 2. And then 0 plus 3 times 1 over 2, x negative 1 over 2. 5 minus root 0 minus negative 1 over 2, x negative 3 over 2. And that's not the end. Unfortunately, that's not the end. It's 3 over 2, x negative 1 over 2. 5 minus, now to make this better, I mean, it's easier to expand, I will do this. I think, to me, that's easier. You may not agree with me, okay? And that's not the end. You have to do 15 over 2, x negative 1 over 2, minus 3 over 2, x negative 1, plus 4, x negative 3 over 2, minus 3 over 2, x negative 1. Okay? And then you put it, I think, still in descending order. Is that okay? 15 over 2, x negative 1 over 2. This one is minus 3, x negative 1, plus 4, x negative 3 over 2. And you will leave your answer like that. If you write the radical sign, I will feel too much to read, basically. And it will be too much for you too. And like I said, you don't have to rationalize, right? Although in the denominator, you have a third. You don't care, okay? You don't care. Part B. Prime when x equals 4. 15. This is 4 to the power negative. That's 1 over 2. Now you can use the calculator, okay? Okay. Okay. I think this question can show you just how complicated each question can get. So the other day, I was invigilating another class, and they, not invigilating, maybe, I don't remember, but it's another class. And they were maybe just S6 or whatever. They just like, I gave them a whole page and a second page to write on. And then when they finished the first page, they just refused to use the second page. And when I asked them, why don't you use the second page? Why are you trying to squish everything and get everything crammed in the same on the same page, and it's so difficult to read? And they told me, oh, Miss Chen, I don't want to flip. And I suddenly thought of you. I said, oh, I must remind the S5 girls that you must always be ready to flip, okay, to another page. It's very common that these questions need very long steps and you will have to use the second page. And just because you are not used to flipping, you must get used to that now. And the simple question like this takes a long time. It's expected, okay? It's expected. Now you try. Now you try. Use the product rule, okay? And then you tell me the answer. When you're done, you let me know. Turn on your cameras. Okay. I will show you my answer. If your answer is different from mine, please let me know. Now, in my final answer, I arranged all the terms in descending order. I hope you do the same for me. Otherwise, it's very difficult for me to check your answers, okay? And then I hope that you write your answer like that. You don't have to write the positive index. Charmaine, 29. So your answer is different from mine? It's 19.5, yes. Oh, I got it wrong. This 15 plus 8 is 23. 23 minus 3.5 is 19.5. Yes. Yes. The answer is 19.5. Okay. That's it. That's it. You would need, I think, a few times to try. I mean, assignments to try out. Now, when you are doing your homework this time, you check your answer before you hand in. Okay. Do you know that? You check your answer before you hand in. Extra example. Now this time, if we have 3 functions and then we multiply all of them. Now here I write u, but u is f of x. U is a function, okay? U is a function. G is a function. H is a function. Now, why don't I write FGH? It's the same. You can write FGH. You can write DDX FGH. FGH. Okay? It's the same. Just don't be alarmed if you have UVW. UVW is just equal to FGH separately. Okay? Now, you need to figure out the rule to find the derivative of the 3 functions multiplying. And you need to show that this is the rule. Wow, you need to show this is the rule. Now, to show this is the rule, we do not use the first principles anymore, although you can. You can try, but it's not easy. In my mind, you may have to add a few terms and subtract a few terms, but let's not do that. Let's use some other ways. Can you think of this way? So ddx UVW by the product rule is ddx UV times W plus UV times ddxW. Agree? Even though you have the product of 3 functions, you can just see this result as the product of 2 functions, where you see UV as a whole. UZ is 1 unit. Okay? And then for this one, you have ddx U times V times W. Oh, no. Plus U times ddx V. And then times W. And then UV ddx W. and then you expand it. D dx u times vw plus uw dv dx plus uv dw dx. Do you see? So if you have three functions and they multiply and then you want to find the derivative, it's very similar to the other product rule you just learned. You just take each part, you take each factor. Let me say it this way. You take each factor, you derive each factor, and then you multiply the rest, and then until you do that to every factor, and then you're done, okay? Now, using that, d dx u, this is u, this is v, and this is w. This is part b. This is equal to d dx, the first one, multiply the second two. Now, you just multiply 3x plus 2, x plus 1, and plus copy the first one, copy the third one, and d dx the second one. And plus, you copy the first one, copy the second one, d dx the last one. Okay. Now for the first one, it's 2 x derivative is 1x 0, that's 1. So it's 2 plus 0. And then this one you need to expand 3x squared plus 3 plus 6x plus 2, or 5x plus 2. And for the second one, this is 2x squared plus 3x plus 1 times 3 plus 0. And then the last one is, it's not easy, I guess. I'm not saying this is like something easy, but at least this is fun, it's doable. Okay. Now, in the end, you are supposed to expand and put everything together. Now, I'm going to do it mentally because I don't have space to write it down. You may need more steps. So this is 6 plus 6 plus 6, 18 x squared. And 10 plus 9 plus 7, 26. And 4 plus 3 plus 2, that's 9. Okay. So in the end, we have a little extension of that. 2x minus 1. Oh, please. Ah. Sorry, I made a mistake. Made a mistake. It's 2x minus 1. Then it's all wrong. Sorry, made a mistake. Wow. It's like in your homework, you check your answer before you hand in. If you know your answer is incorrect, you don't You don't, and then you correct it and then you hand it. Otherwise, you're gonna correct anyway in the end. Okay. Last part, the last rule today. It's a very long lesson. How many rules are we having now? The constant rule, the power rule, the constant factor rule, the sum and difference rule, the product rule, and now the last one. No, the last one, the quotient rule. Quotient rule, you can guess what it is. That is the difference. The quotient of two functions. How to find the derivative. This is even worse. This is even worse. Now, to memorize this one, I think is just as hard as to memorize the quadratic formula because it's a fraction. Now this f, I call it high. This one, I call it low. You know, I'm referring to the position inside the fraction. So the final answer of this derivative can be shortened to d high low minus d low high. This is d low. This is d high. D high low minus d low high divided by low squared. Because I don't think it's very efficient if you memorize dfg minus fdg divided by g squared, because you don't know what f and g are. But it's easier if you say d high low minus d low high divided by low squared. Okay, let's prove it. Just write fast. Write fast. Let's prove it. ddx f of x divided by g of x is equal to limit f of x g of x plus h minus f of x over g of x divided by h, and that is limit. Now this one you will see it's g and then h f g minus f g. Okay, now you can already see. Okay, now for the first part, I'll just leave it alone because this part will give me g squared. My answer has g squared, remember? Now this part, I will add something and subtract something again. This one I will get minus f x g of x plus f of x g of x. Okay, now here I am subtracting and adding f times g. And then this is limit g. This one, the first one is g bracket f of x plus h minus f of x divided by h. Okay. The second one is minus f of x bracket g of x plus h minus g of x divided by h. Now here, this one, put them together. Okay. Now, right now, I hope you see a few parts like this part. Okay. This part is df. This is d high. This part is d low. So in the end, it's gx squared. And then this is g f prime minus f g prime. So that is why it's d high low minus d low high divided by log squared. That's the proof. That's the proof. I think the proof is obviously difficult, much more difficult than the previous rules. Even though the power rule, we didn't prove it. Technically, the power rule is more difficult. We can't even prove it. But the skill that we use in this, it looks more difficult. Besides, the application is also not easy because you always have to remember to do that. When you see a fraction, you remember to do that. I'll show you how. I think only one example. 2 examples. Oh, have to hurry. This one. This is a fraction. dy dx is equal to d high low minus d low high divided by low squared. Okay, and it's equal to 0. This one is 3. 3x minus 2 squared. So it's equal to, this is 0, this is minus 3. Then you're done. Show you another one. dy dx equal d high low minus d low high divided by low squared. So in this case, seven minus 9 minus 0. This is 4 plus 0. And then you will simplify. Minus, sorry, I was having a stroke. Minus 28x plus 36 divided by 4x plus 1 squared. And then this one is 42, 4x plus 1 squared. 42, 43. What do I say? 43, okay? 43. Yes, that's how you do it. You do it and you let me know, and then we end the lesson. Okay? You raise your hand and then we end the lesson. Okay. Now please check your answer with me. The first answer is this. Part B. The answer is this. Now, I will keep the denominator factorized. I will not expand. It's the same as the chapter 9 rational functions. It's either factorized or expanded. In this case, the denominator is fully factorized, but the numerator is fully expanded. That's okay. Do you also check if this can be factorized and in the end simplified again? I think you should check it. But in this case, I don't think so. I don't think you can have a factor of 2x minus 7 again. When I say I don't think so, I actually checked. Otherwise, you will further simplify. But that's the final answer. Is that okay? Now we have one more example to go. But you have learned quite a lot today. You have. You will do the exercise and see how far you can go. The last question is just more complicated. You don't have new rules to apply. I will try to assign less complicated questions in the homework assignment. Okay. I'll see you next time. If you have questions, you can stay.